Welcome learners. Today we are going to be discussing about the gamma radiation. Now the gamma radiation doesn't actually occur spontaneously. It is emitted alongside with alpha or beta particle. But the biggest difference lies in its nature. While the alpha particle is composed of helium atoms and the beta radiation, the positron or electron, the gamma radiation is basically just an electromagnetic wave. So it is undisturbed by the magnetic and electrical field surrounding it. Also, it contains way more energy than any other electromagnetic waves we know of. If the electrons emit some energy in the form of light wave, it usually falls under visible range. I think it's just because the nucleus emits the gamma radiation, packing up a portion of its enormous nuclear binding energy. We get an electromagnetic wave which carries more than 1,000,000 electron volt. That's why we find the gamma radiation in the furthest left of the emission spectrum. So now let's dig deep into the source of the gamma radiation. Here we have ourselves a very typical example which you will find in the books of NCERT. A cobalt nuclei undergoing negative beta decay, giving us a nickel nuclei in the process. Now the nickel nuclei we see here is in its excited state. So to reach its ground state, it must release some energy in the form of electromagnetic wave. It does so by emitting gamma radiation in the form of packets of photons. In this particular scenario, we get two types of gamma radiation consisting of energies respectively 1.17 and 1.33 million electron volt. So you can imagine from this simple example why the penetrability of the gamma radiation is maximum among all the other waves. That's it for now. See you again.